Hello everyone. We do statics question solutions. Our topic, two-dimensional force systems. Our question, the resultant of the force system consisting of three forces applied to the arm in the figure, the line of action of R passes through point B, find the magnitude of the force F and write R in terms of unit vectors. Now, before moving on to solving this problem, I recommend you to think about how to solve this problem. If you do this, I think you will understand the problem better. Let's move on to solving the problem. We have three forces. The sum of all three of these is a force, the resultant. We call the forces we have components. We know from Varignon's theorem that the moment of the resultant about a point is equal to the sum of the moments of its components about that point. At what point do we take moment? About point B. If we take a moment about point B, the moment of the resultant will be 0. Because it is said that the line of action of the resultant passes through point B. So, to make our work easier, we take moment about point B. When we take moment about point B, the moment of the resultant is 0. The sum of the moments of the other components is also 0. Let's take the moments of the components, add them up. Let's first take the moment of 30 Newton. By the way, sure, we have sign convention about moment. We take counterclockwise moments as positive and clockwise moments as negative. This choice is arbitrary. Anyone can choose as they wish. We can see from the figure that 30 Newton creates a counterclockwise, that is, positive moment. The moment arm of 30 Newton is 3 meter. So its moment is 30 multiplied by 3, positive. Let's move on to the other force, 36 Newton. 36 Newton's moment about point B is clockwise, hence negative. Moment arm is 1.5, 36 multiplied by 1.5. Finally, let's find the moment of force F. We use Varignon's theorem to find the moment of the force F. I shift the force to where it intersects the x-axis, splitting it into two rectangular components there. The sum of the moments of the components is equal to the moment of the resultant. The x component does not generate moments, because it goes through B. The y component is just creating moments. Before we write the moment of the y component, let's write the y component first. For the y component, we use the slope of the F force. A 5, 12, 13 triangle is given. The y component is multiplied by 5/13. Its moment is found by multiplying it with the moment arm. It is clockwise, it is negative. Moment arm is 4 minus 1.5. We took the moments of all the forces, summed them up and set them equal to 0. From here we draw F equals 37.44 Newton is found. We have solved the first part of the problem. Let's move on to the second part. R is required to be written in terms of unit vectors. Let's write R in terms of unit vectors. R equals our xi plus our yj. We need to find our x and our y. From the relation Rx equals sigma fx we will find our x. That is the projection of the resultant to the x-axis is equal to the sum of the projections of the components to the x-axis. Let's sum up the projections of the components on x. 36 Newton has no projection to x because it is perpendicular to x. The other two forces have an x component. The x component of the F force is negative, the x component of 30 Newton is equal to itself. It's also negative. When we add them up, we get minus 64.56 Newton. Let's move on to Ry. Ry equals sigma Fy. The projection of the resultant to y is equal to the sum of the projections of the components to y. Let's sum the projections of the components to y. The projection of 36 Newton to y is equal to itself, in the positive direction. The projection of the force F to y is in the negative direction, F multiplied by 5/13. The projection of 30 Newton to y is 0, because it is perpendicular to y. Adding these together, we get 21.6 Newton. We can now write R in terms of unit vectors. We write these values in place, we have obtained and written R in terms of unit vectors. Goodbye.